All right, we are in geometry. Today's date is Tuesday, February 25th. I did not make a mistake on the date today.
I came back.
It's actually Tuesday. We're talking about arc length, which is the natural thing when you're talking about circles from arc measure. Gunner, what is our objective?
That was kind of rude. That was kind of rude. I don't care.
Come on, guys. Let's try to keep it respectful in here.
Use the relationship between arc length, circumferences, and central angles to solve problems.
There it is. And there is a very strong relationship between those things. Let's talk about it. So first, some vocab. If I talk about circumference, does anyone know what the circumference is? A way to define circumference? One person that doesn't have a card. What is the circumference? We talked about it yesterday. Circumference.
Circumference of a circle.
Yeah, what is the circumference of a circle? Quiet hand. All right, Gunner, go for it.
Isn't it like the whole outside of the circle?
Yeah, the whole outside. So in terms of, I'll call it like the length of the outside. So say the length of the edge of the circle. Well, we were talking about circles, so I'm just going to say the length of the edge. We know that we're talking about circles. So that means if I were to get my battle axe out and chop the circle right here, and then okay, I will peacefully rip this circle and then unfold it to a straight line. The length of that straight line is the circumference. How long is your circumference? Or you can think about it this way: I don't have to rip or break anything. If I'm a peaceful ant that's walking around the edge of this, how far do I have to walk to go back to where I started? That's the circumference. All right, what about the radius? You guys know the radius. That was like 8th grade, right? Jessica?
Is it like the point to the edge?
Yeah, center to the edge. I guess it's the distance from the center to the edge. But yeah, center to the edge is the main thing you need to know. So let's go ahead and draw a radius. Everyone with me right now. A radius, again, from the center of the circle out to the edge, a straight line. Let's label it lowercase r. Typically we do lowercase r for radius. I'll put that off to the side over here. Let's zoom in a little bit. Too much. Okay, arc length, the thing that we're talking about. Notice that's the title of today's lesson. What is the arc length? I need you to use the word circumference in here. So it's not the whole circumference. Anyone want to take a stab at it? Take a guess?
That's way too much.
Well, I'm very violent today, I guess. I'm sorry. I need to tone it down. Anyone like to make a
Too much video game.
warm-hearted attempt?
Too much class. Too much Minecraft.
Gunner again.
Isn't it like a part of the circumference?
Part of the circumference. I'll type it verbatim. Sounds good. Yep. Arc length. That means if I am, again, that warm-hearted, lovely ant that's walking around this edge of the circle without any sort of destruction happening, I am walking from here to here. How far do I walk from here to here? That is the arc length. How far do I walk from here to there? That's the arc length. So if I'm not talking about just a piece of the circumference, arc length. Notice that there's no degrees. Now I'm talking about like how many feet or how many yards, how many meters am I walking? It's some length, some distance. Okay, so again, some review from, I think, 8th grade, 7th grade. Sometime when you learn circumference, what is the formula for circumference? There's a pi in there. There's a 2. There's an r. Very similar to the formula for an area. Julian,
2 pi r squared.
you're really, really close. I'll let you call someone else, Julian.
No.
2 pi r. Yeah, you just added an extra square in there. You didn't need to do that. It's just 2 pi r. So notice that I haven't formally defined it yet, but the diameter is twice the radius in terms of the distance. That means if I continued this line twice as far, the diameter is twice of the radius, right? Which means twice of the radius. I can really rewrite this formula a little simpler. It's less useful, but there is another form of this. I can also say, I'll use a second color here. This is the same thing as pi times the diameter. And d here stands for diameter. Which is really kind of beautiful to me. It's this very simple formula. Hey, if you have this really cool ratio of pi, then multiply by the diameter, you get the circumference. And actually, the definition of pi is it's the circumference divided by the diameter. That's how we find pi. Yeah, Sergio.
So, like
Exactly, yeah, that full length. Yep.
Wow.
Yeah, and then we're probably going to use pi in our answers unless it asks us to estimate. But for the two problems that I have for you, we will get an exact answer that has no infinite decimals. You'll get it exactly. All right, so here is your formula. And generally speaking, this is going to be a theme throughout this entire unit, so try to get used to it now. The general, we're going to have tons of proportions. The general proportion that we're going to have is part over whole is equal to part over whole. That's the general theme in almost every single one of these. It's going to be part divided by the whole equals part divided by the whole. That's what it's going to be right here. So I'm going to talk about the part of the angle and the part of the circumference. So in this case, this ratio on the left-hand side, that's going to be our angle. On the right-hand side, that's going to be our length. I guess I can say arc length. All right, so let's actually write out what this fraction is. So that was just me labeling the fractions. Hopefully that doesn't confuse anyone by having fraction over fraction. All right, so I don't know what angle I have, so to have some sort of part of an angle, I'm going to call that theta. Theta could be the whole circle. It could be 360 degrees. It could be 70 degrees. It could be 29.8. Some part of the angle. I don't know how much of the circle's angle I'm using, but some part of the angle. Some part of the angle, and then the whole angle. How many degrees are there in the entire circle with a quiet raised hand? So the whole angle for the circle, how many degrees are there in a circle?
Whoa.
Julian, don't you have your card turned in?
No. That was wrong.
Even if you get it wrong, you still have participated. That's okay. Okay, Julian.
Oh, no.
360, perfect. Everyone write it down. This is 360 degrees. So part of the angle is theta. The entire angle is 360 degrees. We have defined what part of the arc length, or part of the, I kind of gave it away. What is part of the entire length called? With a quiet raised hand, Andres? Yes, Andres?
The length of the arc length.
The arc length, yeah. So let's write it up here. This is the arc length. Arc length. And typically, I don't know why, but we call this variable s. So on Khan Academy, you'll see s, and you'll be like, wait, why are they putting s there? S stands for arc length. And then what about the whole? So if part of it is the arc length, what is the whole? It's going to be part divided by whole. Part is the arc length. What's the whole? The whole distance around the circle. We just defined it up above. The whole. Yeah, Jose. That's the angle. I'm talking about length now. One of these three words that we defined up above in vocab. Exactly, the circumference. So everyone write it down, circumference. And normally I could put a C here, but instead of putting C, I'm going to put the formula, or I'll write C and the same thing. I don't know. I don't want to be too confusing. Let's just write 2 pi r. So I can boil that whole formula into this. It looks really complex, but it's theta over 360 is equal to s over 2 pi r. If that looks confusing, it's because it does look like a bunch of gibberish, but it's the part of the angle divided by the entire angle is equal to the part of the circumference, the arc length, divided by the entire circumference, 2 pi r. This is the formula we're going to be using over and over today. That's it. There's no additional information that you have to have memorized. You just need to be able to memorize this and use this. If you have that, you're meeting the objective. This is the relationship between our angle, by the way, this angle right here is always going to be your central angle. Let's write this too. This is our central angle. So we have our relationship between arc length is s, we have circumference, which was 2 pi r, and we have the central angle, theta. So we're meeting our objective now by talking about all of this fraction. All right, let's use this fraction. So I want to find the length of this arc. It's kind of hard to see, but it's not this pi piece right here. It's this piece right here. How long is that arc length without that piece? How am I going to do that? Well, first, I'm going to write down our formula. So everyone copy down the formula yet again. Try to do it from memory because you're going to have to memorize this. Theta over 360 degrees. Part over the whole is equal to part over the whole. All right. Someone talk to me. What do we know? And if you have your card, please raise it. Yeah, Andres.
We know that the central angle. Oh wait.
What about the central angle?
Circumference of 12 and the central angle of 300 degrees.
All right, so what does that mean? What's being plugged into our formula?
S is going to be, theta is going to be 300.
Yep, so, oops. Yeah, so this theta right here is changing into a 300. Everyone copy it down too. This is now going to say 300 over 360 is equal to something over something. And then did you want to use that 12 too?
Yeah.
Where does that 12 go?
It goes S, where the S should be.
Careful. So
Where the R is.
I might have confused you by writing down too much. So this bottom piece is the circumference, which means I can replace this entire 2 pi r. That's all gone now. That is circumference. So where does this 12 go?
That goes under S.
Yeah, it's going to be S over 12. Yeah, and I just want to make sure everyone understands. This 2 pi r is circumference. And if it says the circumference is 12, well, we can just say that's 12. So if you don't like writing 2 pi r and you think that's going to confuse you, you can just write C for circumference. I like writing 2 pi r because it's going to help us, I think, especially in future examples. All right, and then we solve. We need to solve for S. We're trying to find the arc length. Notice that we only have one variable, which means we're in Algebra 1. One variable. We can solve for that. How do I solve whenever I have a fraction equal to a fraction? Quiet raised hand. I'm definitely going to have to cold call someone if they don't have the card. And Andres, let me take your card before you use it. Jenny. You do indeed. Cross multiply. You want to do that for us? All right, what's the first one going to be? You don't have to multiply, you just have to write out what's going to happen. 12 times. Perfect, keep going. Equals 360s. Perfect. All right, so Jenny has cross multiplied for us. We need to figure out what that is. Well, I'll give you this hint. So 12 times 3, I'll ignore the 300. 12 times 3 is 36. And then I add the 2 zeros on. So this is now going to read 36 with 2 zeros. 3,600 is equal to 360s. Ooh, this is some interesting similarities in the structure on the left and the right. They look very similar. One just has more zeros. What is the next step? How do I solve for S? Quiet raised hand. What do I do to both sides? Someone that has their card. Whose card are you raising?
Oh, mine.
What?
Because it's in my hand.
I have your card. Whose card are you raising? Cohen, go for it. Don't let him take your card.
It's not his.
It's not.
It's
Is
not
it Jenny's?
It's not Jennifer's.
Whose card are you holding?
Wait, can I just answer it now?
Jenny.
Yenny.
But Jenny already participated. No, it has to be someone else. Someone that has their card.
Yenny.
We'll go with Cohen. What do I do to both sides, Cohen? Perfect. Divide both sides by that coefficient out front. Divide by 360. Gone. And notice that what happens over here is we have a 3 canceling out, the 6 cancels out, The 0 cancels out, and it's not a 0 that's left over, but it's whatever 3,600 divided by 360. Does anyone see it? What is 3,600 divided by 360? You can do this in your heads. I believe in you. Is there a quiet raised hand that can do it? Jose? It is indeed 10. Cool. So everyone write down S is equal to 10. There's our final answer. Box it.
So that's the final answer, final, Mr.
Final answer, because it's asking what is the length of the arc? What is your arc length? Well, S represents your arc length, and the arc length S is 10.
Okay, so like the whole
Which
doesn't make sense though.
which means
Little like slivers. Well,
the 12 is talking about the circumference. If the entire length is 12, just the red length is 10, which means that this arc length right here must be 2. So it's 2 and 10 to add up to 12.
is there a shortcut to this? Yeah.
Nope, it's going to be the same fraction. Well, I mean, once you understand the fraction really, really well, you can see a few little shortcuts. But you have to understand this fraction first as a prerequisite to all the shortcuts. It's not going to help you that much because, again, it's heavily referencing this fraction.
Okay.
Let's try example 2, and then we can be, I think we're done. Yeah, there's no backside. Example number 2. All right, so we have this circle over here. It has a radius of 3, and it tells us its arc length. This arc length right here, in case you can't see, it's this length right here. Just that length right there is 6.28. Oh, and this one we do have to round. I lied to us, sorry. Oh, teachers do it all the time. At least I apologize.
That's another random on that.
Round to the nearest whole degree. What is the central angle now? Again, set up your proportion. Try to memorize it. Don't look at your notes too much. Don't look up above. Write down the proportion from memory. You're going to have to memorize it anyway. If you don't know, you can look up at the board as well. How well did you memorize it? You're checking your formula. All right, so next, what can I plug in? Whose card do you have now? This is Cohen's that he didn't turn in.
Wait, what? That's kind of a mean comment. That
Don't let him steal your cards. Turn it in, please.
I'm the card stealer.
All right, who still has their card?
No, can I have that card?
All right, thank you. Eder, go for it. What can I plug in? What do you see? I have 3 and 6.28. One of those can be plugged in. Where do they go? Three goes where? 3's R. Yeah, okay, so let's go ahead and write down what Eder said for us. So we have definitely divided by 360 is equal to something over 2 pi, and then R is now 3. All right, what else can we plug in? Thank you, Eder. Monse. Yes, 6.28 goes right there. That is our arc length. It tells us arc length is, or of 6.28, and S represents our arc length. What do we do over here in the top left? What do I, oh, question, Andres?
Yeah, so you want to replace 2 pi r like the whole thing just r?
This case, we only have radius. It says radius is 3, so we can't replace it. If it was circumference, then yeah, the entire thing can be replaced because circumference is 2 pi r. Yeah, good question. And it is a bit confusing, I know, but there it is. What do I put in the top left? What is our theta?
Wait. Any more cards? Well, that was really
Sergio. What do I put in the top left? Yeah, say it louder.
Theta.
Yep, theta. We don't know it, so we have to leave it as theta. And that's the thing that we're solving for. We don't know what that central angle is, so we'll leave it as a variable. And our variable is the Greek letter theta, lowercase theta. Okay, so from here I need to solve for theta. What am I going to do? My next step. Quiet raised hand. What am I doing? Is everyone in? No. Fernando. I need to solve for theta. What should I do? What do I do when I have a fraction equal to a fraction? How do I solve?
Oh, you
Cross multiply. Do that for us.
Wait.
So it's 6.08 times 360.
Yep.
And then it's 2 pi times 3.
What's 2 times 3?
Um,
Okay, 6 pi times
5 times theta.
theta. Perfect. Thank you. So Fernando has cross multiplied for us. I think everyone's card is in now. Yeah. Am I right? I know Gunnar picked up something off the ground.
Oh.
Who would like to do the next step? Andres, go for it.
Alright. So you're trying to get.
Trying to solve for theta.
So divide both sides by 6 pi.
Okay, let's do it. Divide both sides by 6 pi. Divide both sides by 6 pi, and then we've solved for theta. Theta is equal to whatever this thing is, and we're going to need a calculator, so let's go ahead and pull up our Desmos Scientific. It always zooms super far out. I guess it's for a tablet or something. Okay, so I'm going to type in 6.28 times 360 divided by, it doesn't matter if it's all divided by, but I can make it look like I have it right here. Divided by 6, and if you type in pi, then it turns into pi. And we get that number, and it says to round to the nearest whole degree. So my final volunteer for today's notes. Can someone round this number to the nearest whole degree? Sergio. 120. There it is.
That's the answer, final answer?
Final answer, box it. 120 is the central angle. And that looks about right? So this would have been 90 degrees, and then that looks about 30 degrees. 30 plus 90 is 120. So we always kind of check to make sure it looks good. All right. Please give me a fist of 5. How well can you do our objective today? To use this formula. 4, 5, 4. Is that a 3, 4, 4, 4, 4. Come on, guys, make it easy for me to see. You're going like this. Guess where I'm at? I'm at.
If you guess it right,
Is that a game design?
Whoa! Like this. How's
that?
Fernando, what do you got? 4, 0, and 4. All right. That concludes our lesson.